A real network engineer versus a certified paper engineer. So, what do I mean by this? There are people who work as engineers, and there's people who only get certifications and think of ideas of what a network engineer or any other tech profession does. I'm going to go into deep into the mistakes people make of people who get certifications and don't learn the real world skills that is required. So, let's start off with an analysis. The network goes down for 5 minutes, right? And companies can lose over six figures in minutes, even before you ever investigate it. I'm gonna say that one more time. Companies can lose six figures. If it's a big enough problem, they can lose over seven figures. So you are solving a very complex problem in this scenario. That's very critical, okay? So knowing that, not the CCNA, not package lab, the job is keeping number at zero. Whenever you're doing a lab environment, whenever you're just doing it for fun, when you're learning IT, just know that there is no consequences. But when you're working at a large company, there is consequences. Okay. There was a time where I caused an outage where I put an incorrect IP address. And then an incorrect IP address blew up that particular router and that point-to-point link on an IPv6, and there was an outage. There was an outage that cost the company money. 40,000 users were impacted. That's a big deal. That's a big deal. So as a real network engineer, you have to think in the context of the customer. The customer is the number one thing that you should be focusing on, and who are you kind of helping? And this is where people make mistakes. They think they're just building out a lab for fun. There is no lab for fun. You're dealing with real customers, and when you're dealing with real customers, there is money on the line. So that is something that you should always remember. Okay. So now this is where people mess up the most, right? They get their CCNA. Fantastic. The problem is they still cannot pass a job interview. They just can't pass a job interview. And what happens to them is they don't have real life experience. Okay. Real life experience is huge. You need to have real life experience, and a certification is not going to get that for you. I wish it did. I wish there was a certification that can give you real life experience, but that doesn't exist right now. Right. So don't think the CCNA is going to be the ticket, the golden ticket to you landing a position or any other certification in tech. Okay. What certs test? They'll test your ability to subnet, to understand protocol definitions, to do packet trace topologies, and answer multiple choice questions. If you can do all these three, you're able to pass the certification. And that's absolutely amazing. I mean, if you pass the certification, that is a big win. And I'm not discounting that. But if your goal is to land a job offer as a network engineer or administrator or network technician, you need more than this. Okay. This is nice to have, but it's not a must have. It's just not a must have. Okay. So, what the job tests, right? When you're working at a job, we use softwares, we use tools, we use specific things like monitoring tools, like documentation, a place like a documentation tool. We use the terminal. We can use like tools like Secure CRT to actually get into the device, things like that. You have to understand how that works. We also escalate work depending on who it's responsible, which requires you to learn communication skills. A lot of times people are not learning communication skills for whatever reason. They think they don't need it. Cool. That's up to you. But communication skills are super important in learning how to escalate tickets, because we use tickets, and that's another software. We use ticketing systems. All these tools are tools that are used on the job. And when you work on the job, you're not doing multiple choice questions. You're not handwriting subnet math problems, although it sounds like you will, but you're not. We use subnet calculators, right? Even in the terminal, there's a way to use a subnet calculator. So stop overthinking subnetting, right? We have to write things up. We have to write up configurations, right? This is something I learned also in the industry. You're going to have to write your own configurations on what is known as a method or procedure, and that has to be configured, and it has to be written, reviewed, and configured, right? Another thing is we go on bridge calls. Okay, bridge calls are a huge part of what we do. We hop on calls, right? In a bridge call, is a call where you speak with a vendor, with someone in, speak with a vendor, customer, whatever, to deal with a problem, whether you're doing an upgrade or you're doing something as big as a troubleshooting session. That is a bridge call, a video call where you're investigating, troubleshooting, working on a particular issue. These are job activities, okay? So this is what happens when you interview, guys. You're interviewing, but you're not saying the right things, and you're freezing up because you have no context. You need to fill in that gap with context, right? And the CCNA gets you to the room, but it doesn't tell you what to do once you're in it. What does that mean? Once you get the interview, you're going to flunk your interviews if you don't have the context of what an engineer does, okay? So why this keeps happening, right? Why does this keep happening to you? First of all, the same pattern over and over again, every single time, whether it's help desk, network admin, or CCNA to network engineer. Number one is gap one, right? Train on protocols, not tickets. You understand every protocol. You know what DHCP is. You know what ARP is. You know what DNS is, what HTTP is, right? You understand some of the networking protocols, fantastic. But you don't know how to solve a problem or work on a ticket that is related to that problem. Right. For example, one of my first ever tickets, you probably know this protocol, is LACP, right? Which is a layer 2 protocol for port channel to add more links to a port. This protocol, right? I had to do a configuration where you do what is known as an augmentation. That augmentation, right, is basically increasing the links from 4 to 8. And when you do that augmentation, right, what's going to happen is you are increasing the bandwidth, right, of that link. But now I have a context of how you would use a protocol, right? This is the big mistake that people make, is they don't know how to use a protocol or when to use it or the context behind it. They just know the definition of the protocol. And when they interview, they can't pass the interview. Next thing is they never touched documentation or escalation, right? They've never looked at documentation. They've never had to escalate a ticket before. They never, done these types of activities. So these are some of the activities that you should be implementing, okay? And no one grilled you on why. Why do we use OSPF exactly? Why are we using BGP over OSPF? Why? Just tell me why. Don't tell me the definition. I don't care about the definition, but tell me why. And if you can't tell me why, you don't know why. And that is the worst area you can ever be in, okay? Next thing is the fix, right? The fix isn't another certification. It's replacing the missing rep, okay? And we'll cover on how to do that. Now, next thing is understanding a protocol list. Everything looks equally important, right? When you're trained on protocols and tickets, you think, oh, VLANs, STP, OSPF, BGP, ACL, like these are all great protocols. Some protocols matter more than others. For example, the one that sticks out to me is BGP. BGP can cause the most damage out of all these protocols, right? Because that's a protocol of the internet. It can pretty much shut off the internet if it's working incorrectly. Understanding how STP can cause issues with broadcast norms, maybe coming up with a story of how you can use that, right? So that is a big thing. That is a huge thing, right? And if you can't explain a protocol and the use case of it, but not only the use case, but what would happen if it doesn't work, right? What would happen? What's a common problem we face with these types of tickets? For example, an ACL, right? Tons and tons of tickets. Sometimes we have to add an ACL to we have to add a new rule to the ACL. Sometimes there's already a current ACL. We have to add a new rule to it. That new rule can be, usually with ACLs, you add new rules. Typically, if you're adding a new device to your network, you want to permit it. But maybe we have to add the ACL and we have to inject it in the middle of the ACL block. Right now, we're getting into a little bit more advanced stuff because ACLs, they go, from top to bottom. And if you add a new ACL, automatically goes to the bottom. We want to inject it to the middle. So you want to make sure you add the number in the front. Things like that context can only be done by doing tickets and examples. And that comes from doing projects that are related to job-related activities, okay? Next thing, gap 2, no one taught you documentation, right? One of the first things I learned about after getting my first job as a network engineer is how important documentation really is, It's absolutely critical to understand documentation and be able to use documentation the right way. So, what is documentation? All documentation is, it's a Wikipedia page with exactly how to do stuff. That's all it is. But whenever you're creating something new, you worked on a new project, you do something new, you want to put in the documentation so next time the person who sees what you did can see exactly how to do it. Another place you do documentation is every single time you do a network change. You want to document every single step that you did on that network change. Very important that you document every single step, because if you document every single step, then you're going to have a place of documentation, right? And we usually do that and then put that in an email and send it over to, we usually send that to the whole team. That's how we use documentation usually. How did you decommission the device? How did you request for change approval? Things like this. What is change approval? Change approval is every time you make a change on the network, right? Someone has to review that change and make sure it's good to go. That's change approval, right? How you hand off a ticket to the next person. Whenever you get a ticket, sometimes you can't mark it as complete, but you have to hand it off to the next person, or you can mark it as complete and hand it off to the next person because you've done your part. Maybe you have to hand it off to the systems team, to the video team, right? To the DOCSIS team, right? Right? Things like that are going to be super important to really understand. And then gap 3 is, no one, like I said, grilled you on the why, right? Interfaces are up, pings pass, it worked, right? But underneath, redundancies, flat network, wrong protocol, falls over, second something. So here's the thing. Just because it's green and working doesn't mean it's working. You want to dive deeper and check everything. Check spanning tree, check ARP, check the routes, check to see if it's actually routing to the right location. Check to see if you followed the standard documents that were set forth by the senior engineers. Right? You just because it works doesn't mean it's working in the right way, in terms of the right way that the senior engineers designed the network. Right? Because usually what happens is principal engineers will design the network a certain way and only allow you to do these certain ways. Like you can only use these blocks of IP addresses. You can only use OSPF on a network. You can't just use any rogue dynamic routing protocol that you want to just use. No, that's not how it works. Right? Things like that are going to be mission critical. So how do real network engineers think now? The first thing is the symptom. We first have to see what the problem is, right? The first thing we have to see is what is causing the problem. Is it really a problem in the network? Is it a fake problem? Something like that. Once we've identified that as an engineer, then we can see and find the root cause. What is the root cause? Finding the root cause is the biggest thing. What caused this problem? What caused this outage, right? If an interface is down, you want to go to the root cause and find everything. You want to start with layer 1, obviously, because the port is down, and see why it's down. Did the port flap? Was that up recently? Did the port go down? You want to figure out why it went down and when it went down, and then what caused it as well. Is it maybe the fiber cable got cut? Was it the SFP got, whatever reason, got just broke? You want to find the root cause. Once you find the root cause, then you want to document it and let people know, okay, this is the issue. This is what's happening, just so the person knows it. And then maybe you have to ask people to put things in place, and that goes into the fix, right? Then you may have to set an RMA request, right, to replace it. Let's say the SFP broke, then you want to go and set the RMA request, right? And then at that point, the issue is fixed, but you've documented it, you found the root cause, and you found out what the problem is. That is the biggest thing. So when it comes to all these aspects, when it comes to becoming an engineer, a network engineer, right? Or any engineer rather, you have to focus on these aspects. Stop focusing on memorizing configurations. Stop focusing on memorizing protocols and learning how to paper subnet. Yes, that's great. But at the same time, think like an engineer, because you're going to interview like a robot and say, DHCP stands for this. It stands for Dynamic Host Configuration Protocol. Hopefully that's correct. No, we don't care about that. You want to say DHCP is a protocol that dynamically assigns IP addresses to hosts on a network. It's really good for large enterprise networks. We have multiple users, so that way you can automatically assign IP addresses without having to do any manual configurations. And if they wanted to elaborate further, you would go into the DORA process and go in depth with that. That is how you answer questions, because that shows your depth of knowledge, and that is where people mess up. Okay. But that's it. That is what I recommend. Okay. In terms of getting the skills of an engineer. Now, how to actually get these skills as an engineer, I have a program that helps people go from zero to landing their first job as a network engineer. There's a link in my description. We've helped multiple people go from zero to landing their first job as a network admin at amazing companies like Amazon, Google, right? So if you're interested in this, there's a link in my description. We help people go from zero, teach them the basics of networking, going over what we talked about here, teach them the exact skill sets, exact tools that we use as engineers. That way, when you interview, you can sound competent, be able to pass your interview, and excel in the job. If you're interested in that, there's a link in my description. But if you guys liked the video, give it a like, and I hope you guys enjoyed it, and peace.